Hi Divyanshi, can you hear me? Divyanshi, can you hear me?
Ma'am, your voice is cracking.
Okay, please try the problem on the board and share some ideas, okay?
Ma'am, what do you mean by degenerate quadrilateral, non-degenerate quadrilateral?
It's basically quadrilateral such that like it's not like a triangle with a point on one of the sides. Or it's not like a straight line where all points are on the straight line. Like it's a proper quadrilateral with four sides. Does that make sense? Can you please repeat the definition of the non-degenerate quadrilateral? It is a quadrilateral with, I guess, positive area. Okay, not really positive, but it should have four proper sides. Like this is a non-degenerated quadrilateral, but this quadrilateral. This is a degenerated one, and even this is degenerated. Is that fine? The degenerate quadrilateral resembles triangle, no ma'am? It could be a triangle or a line. Okay, ma'am. Okay, how about we look at M1, M2, M3, M4? Can you say something about it? Can you see that M1, M2 will be parallel to PC?
Yes, ma'am. Can we apply midpoint theorem over here?
Exactly. Like this will be parallel to this because of midpoint theorem. Can you say M3, M4 will also be parallel to AC?
Ma'am, by using same theorem.
Exactly. So can you say this is a parallelogram?
Ma'am, the correlateral M1, M2, M3, M4.
Yeah. Okay, if you look at a square, can you prove that diagonals also pass through M? In a square.
Ma'am, for this you have to prove that ABCD is a square for the midpoint and M to coincide. The midpoint of diagonals
Yeah.
and M to coincide. Ma'am, but it is not given in the question.
No, if you take a square ABCD, then can you prove that the point M for ABCD and the diagonals coincide?
Ma'am, this is the direct property of a square.
Exactly. So if you look, can you say M1, M2, M3, M4 is also a square?
Yes, ma'am.
So for this, if you take midpoint of M1, M2, M3, M4, let's call it M1, M2, M3, and by the given equation, we have f of m equals f of a plus f of b plus f of c plus f of d. And if you look at this triangle, this square, and use the same property, what can you say?
Ma'am, how can you relate coordinate geometry with algebra?
That's the whole point of the class, to relate coordinates and geometry with functions. Okay, I guess I didn't go over what the function is very nicely. So the function is like if there's this plane, so it takes any point on the plane and assigns it a number. Let's say this is given 4, this is given 1, this is given 5, and rest all points are given 0. That's a function, right? You're just taking a point and assigning it a number. Yeah.
Ma'am, you have taken the points randomly, or is it given according to equation or function?
Yeah, for like in this case, we're taking it randomly. In this case, we have a condition. Is that fine? Okay, how about this? There can be many types of functions. Let's just go over a few types. 1, 2, and let's say this is like your entire plane, and then you're assigning every single point in this plane a number. Let's say this region, assign all the numbers 0, then this region you assign all numbers 1, you assign this number 5, this number 6, and rest all you assign 3. Is that a function?
Ma'am, but doing this thing, what purpose will it serve? Ma'am,
It's just a function.
yes, ma'am,
Yeah.
but you're assigning numbers randomly. Rather, we can use do coordinate geometry over here, where we have a plane and the coordinate system.
Yeah, you could also do that. Like, let's take a point A. Its coordinates are x comma y, then f of A equals x plus y. That's also a function. Or f of A equals x squared minus y. That's also a function. Right?
Yes, ma'am.
There's also functions like point to point. Let's say there's a plane and then there's a point A. So f of A equals a point B such that P is just one unit right first to. So this is x comma y, this is x plus 1 comma y. This is also a function. Is the definition of a function clear now?
Yes, ma'am.
Now I guess you can try that. Well, I guess I'll just 5 minutes.
Ma'am, in a traditional way, whenever a function is made, like there has been a mapping from a domain to a range, and then that is plotted. Hence, we get a graph, and that graph is serves as a geometry. Ma'am, but over here, where the mapping is from?
It's from set of points to real numbers. So f is from the plane, let's call the plane S to R. It takes every point in S and assigns it a real number.
Ma'am, then
Gunjan,
it does by a spec.
Gunjan,
Mm-hmm.
can you just make the screen larger a bit, because I think it's hard to see the problem. Oh, okay, thank you.
So the function is okay. Let S be the plane, and then the function is from S to set of real numbers. We take every single point in S and assign a real number to it. Is it more clear now?
Yes, ma'am.
And
Can we write m is equals to b plus d by 2 is equals to a plus c by 2 is equals to m1 plus m3 by 2 is equals to m1 plus, no, m2 plus m4 by 2, and then equal all of it and cancel out.
Can you repeat?
Ma'am, m is coming b plus d minus a plus minus c.
Wait, f of b plus f of b
Yes.
minus.
Ma'am, whole bracket f of a plus f of c. No, ma'am, after minus f of a plus f of c.
Yeah. How did you get this?
Ma'am, using geometry.
Can you tell which quadrilaterals you use the condition on?
Ma'am, the property of square. Ma'am, it is intersection, like the intersection point of diagonals are at perpendicular and bisect each other. And then in the property, and then the square m1, m2, m4, I did it again.
Yeah.
And both the points are coinciding, hence I equaled it.
Yeah, so you basically did f of m equals f of m1 plus f of m2 plus f of m3 plus f of m4. Right?
Yes, ma'am.
After that, what did you do?
Ma'am, after that, ma'am, I'm not getting a clue how to solve next.
Oh, how did you get this thing?
Ma'am, by using the property of square.
Yeah, but the only property we have is here, the relating functions.
Yes, ma'am. Ma'am, so we can't use the property of square over here.
Which property are you talking about?
Ma'am, AC and BD are diagonal. They are both intersecting at point M, and diagonals bisect each other.
Yeah. Yeah, how is that relevant with the functions? Yeah. They're not coordinates, like the function isn't coordinates.
Yes, they are not coordinates.
Yeah, they're not. They could, like, it could be this, it could be this, it could, might as well just be a function like this.
And so how do we relate?
Yeah, okay, so we have this thing, we have this thing. And if you look at this square, what equation do you get?
F of A plus F of M1 plus F of M4 plus F of M.
F of M4 equals f of A plus f of M1 plus f of M plus f of M4. Right?
Yes, ma'am.
Similarly, can you write 4 other equations? is this much clear? Like this is true, this is true, this is true, this is true.
Yes, ma'am.
What else can you see?
F of n is also equals to f of n1 plus f of n2 plus f of n3 plus f of n4.
Your voice faded away there. Is this what you're trying to say?
Yeah.
What can you do from here? Any ideas? How about adding 3 plus 4 plus 5 plus 6? What does that give? Yeah,
Ma'am, it will give you 4 times f of m.
we'll get 4 times f of m plus we get other stuff too, right?
So we get f of m is equals to 7 times f of m.
F of m equals 7 times f of
M.
exactly.
M. So f of m has to be 0. So f of a is equal to 0. Can you see that?
Yeah, we can't see that yet, but what we did take, our special case was ABCD is a square and m is a point. So if you get it for any square, the center of the square is 0, then can you just say that all points would be 0? Like if you take this point, just construct this square. And doing the same things we did here, we can get this as 0. Did that make sense, or was that too fast?
Yeah, so every point can be shown as a midpoint of some sphere.
Sorry?
Every point can be shown as midpoint of some sphere.
We don't do that. We can directly claim everything is 0. That's what we wanted to prove. You got that for a square, the center of the square is 0. Can you say all points are 0 from here?
And how did you prove it?
Was that Nidhi who said this?
Yeah, I think.
Do you want to explain how you got it?
Yeah, so some like from seventh equation, what we know, the LHS will become f of m, and the RHS is summation of f of a plus b, f of a plus b, so on up to f of d, that is f of m. Then we have 4 times f of m as it is, and we have twice f of m1 plus twice f of m2 plus twice f of m2. So that can be written as 2 times Fn. So total we get 4 plus 2 plus 1 7 Fn.
So we have f of m equals f of m plus 4f of m plus 2f of m. Right. Is that fine? I assume it's fine. So now we have this. What
Ma'am,
from here?
ma'am, it is proof that f of m is 0. This doesn't imply that if f of m is f of a plus f of b plus f of c plus f of d, doesn't mean that all the numbers are 0. They
It
must
could
add up
be,
to 0. But we
yeah,
have to prove that all the numbers are 0.
yeah, we'll prove that. So you have this for now, right? We took any square and we took its center and we got it 0. Is that much fine? From here, can you try to prove that if for any square its center is 0, then all points are 0? Let's say you want to prove some specific point A equals 0. You want to prove f of a equals 0. So take point A, then you take a random line through A, draw a perpendicular line to it, and complete a square. Can you get f of a equals 0 now? Is that fine or was that too fast? Or That just does not make sense. Hello.
Yes, ma'am.
So, is this problem clear, or you want like a small summary of the solution? Or is any part just not clear? You want me to repeat?
Ma'am, it is clear.
Everyone else?
Yeah, it's clear.
We could do a similar problem. F is from S to R, where S equals set of not set of things. Okay. Then we have f of m equals f of a plus f of b by 2 if m equals midpoint of AB and there is a point x such that f of x equals 0. Find f. Is the question visible clearly?
Gunjan, please try to write a little bit bigger.
I'll zoom it and write a bit bigger.
Sure.
Now we have to find the function.
Yeah. That is. Okay, how about something easier? Is this clear enough?
Could you show the previous question about the half midpoint that involved the midpoint?
But try this after this question. That's probably what you said.
I think I did some working and I got that all in the above question the same thing that prove that all points in a plane have the same number. F of x is same for all.
Yeah, also there's some numbers with zeros, so what do you get?
So f is 0 for all.
Yeah, how did you
Yeah.
do that?
So I took a line.
Just a second. We took a line.
Yeah. So the endpoints name it as A1 and B1. A1 and B1. And the midpoint be M. I selected two other points A2 and B2 so that M is the midpoint.
Mm-hmm.
So but one equation is f of A1 plus f of B1 is equals to 2 f of m, yeah, and f of a2 plus b2 is same. And I selected a2 and b2 such that they are also the midpoints of a1m and b1m respectively.
Okay, the midpoints of A1. Okay. So this equals this equals this equals this, right?
Yes, and after that, the next we can get equation is f of m plus f of uh, uh, a1 is equals to 2 f of a2.
I'll just write down the steps. This is what you did?
No, I did f of a1 plus f of m by 2 is equals to 2 f of a2.
Yes, f of A2 is this.
Yeah. So then I subtracted. Actually, I subtracted those equations. F of a2 minus f of b2. F of a2 minus f of b2 I did. So that I can remove f of m. Yeah. So f of a2 minus f of b2.
Okay.
Is equals to f of a1 minus f of b1 by 2. And then I got f of a1 plus 3 f of b1 is equals to 0.
How did you get that?
Sorry, f of a1 is equals to f of a2. Sorry, just a second.
Take it to me.
Ma'am, please explain the solution once again.
I'm not planning to discuss the solution yet, but I just wanted ideas. Did you find your mistake in what you were trying?
Yeah, I'd made a calculation mistake. Can you give me 2 more minutes?
Yeah, sure. Also, you have this fact that you haven't used.
Yeah, so let A1 and B1 be those x and y, so that f of x and f of y is 0.
So this value is 0, this value is 0.
So f of m is 0.
Mhm.
And so and f of a2 is also f of a1 plus f of m by 2. So f of a2 is also 0. Similarly, all points on that line become 0.
How do they become 0?
I have taken a2 as the midpoint of a1 and m.
So you got midpoint, like the 1 by 4, like
Yeah,
by
so
sectors become 0.
yeah, so like then there will be a midpoint of a1 and a2, and like that way the entire line would be 0, right?
Exactly. Can you find a more rigorous proof? Like here you're just squeezing everything, right?
Yes, yes, ma'am. Can you give me 1 minute? I'm not able to. I don't have the terms to like state how to like.
We're running a little over time. The proof is not really needed for this problem. I just wanted, like, this problem gives most idea of what we basically can and cannot do. Because in the previous problem, like making equations and this stuff was very new, and I could see that. Instead, how about you guys try this problem? And we're a little over time, so we'll probably stop here. Is that fine?
Yeah. Thank you.
Thank you for joining.
Thank you, ma'am.
If you have any questions, I'll just stay around for a few minutes regarding or not regarding the class.
Ma'am, I wanted to ask that how did you prepare for INMO and the other mathematics Olympiads? Ma'am, like in the mathematics Olympiad and in that they requires a certain amount of thinking, a high amount of thinking. For example, like it is not what have been taught in the school or what is given in the book direct formula application. So how do you build your thinking to that level?
You could read a lot of math textbooks, like the higher math textbooks out there, and I guess solving problems is basically the main thing that helps. Also, should we stop recording here or?
Yeah. Thank you, Gunjan, for the session. Thank you all for joining. And we'll meet you in the next session. Okay. Yeah. Thank you, everyone. Bye.
Bye-bye.